At one point in Earth's 4.55 billion year history, so many species went extinct that scientists call the event the Great Dying. This event was the Permian-Triassic mass extinction, and it radically changed the composition of life on Earth and primed the world for the rise of the dinosaurs. So what happened? From 541 to 252 million years ago, the Paleozoic era on Earth was a pretty good time for life. It began with the Cambrian explosion and saw the development of diverse fish and marine populations, cephalopods like squid, insects, ferns, and the infamous trilobites. The Paleozoic era ended with the greatest mass extinction in the history of the planet. As there's no evidence of an asteroid impact, scientists believe that a volcanic scenario seems likely, and this extinction can be most easily attributed to the Siberian Traps. The Siberian Traps were a large igneous province. Basically, LIPs facilitate the large and rapid release of lava to Earth's surface. The Great Dying began when Siberian volcanic eruptions released carbon dioxide and sulfur oxides. The impacts of the gases released were felt across the planet. The sulfur created acid rain and cooled the planet quickly, while the carbon dioxide, along with other greenhouse gases, destroyed Earth's ozone layer and warmed Earth in the long run. As a fun bonus, the Siberian Traps probably also ruptured coal basins on their way to erupting. In total, they erupted over 720,000 cubic miles of lava and 14.5 trillion tons of carbon. They probably covered an area of about 2.7 million square miles. What were the impacts of the Siberian eruptions? In the atmosphere, oxygen content dropped from 30% to 15%. The planet experienced rapid cooling and glaciations, followed by extreme long-term global warming. Ocean changes included a drop in salinity and a temperature rise. The changes to Earth's atmosphere caused temperatures to go up by as much as 34 degrees Fahrenheit, with sea surface temperatures reaching 104 degrees in just 1 million years. Additionally, nutrient runoff from the volcanoes led to marine anoxia, as algae blooms used up all the dissolved oxygen in the oceans. Anoxia is what happens when no oxygen is available at all. On land, extreme erosion reduced vegetation and ground cover, making life more difficult for land animals. Forests didn't redevelop on Earth for 10 million years following the Great Dying. Anoxia suffocated 96% of life in the oceans, which had lost 76% of their oxygen inventory. Over 90% of species on Earth disappeared. So what are the long-term, really long-term effects of the Permian-Triassic extinction? The Great Dying had a massive impact on the evolution of the biosphere. Due to the details of the extinction, high levels of carbon dioxide and sulfur oxides, dramatically increased temperatures, anoxia in the oceans, some life was able to adapt quickly enough to survive, while most of it was unable to keep up. For example, trilobites, which had dominated for hundreds of millions of years, were wiped out. Species with calcified shells died more than those without. Insects did worse than tetrapods on land. These differences, irrelevant before the extinction began, decided which species carried on and which didn't, which turned out to be most of them. So what exactly happened after the Great Dying? The Permian-Triassic extinction kicked off the Age of Reptiles, or the Mesozoic era. Lasting from 252 to 66 million years ago, the Age of Reptiles saw the evolution of dinosaurs, crocodiles, and pterosaurs in the sky and on land. Higher temperatures caused sea levels to rise around the world, and an ocean covered the center of present-day North America. Plesiosaurs and other massive marine reptiles evolved in the expanding sea, along with coiled shell ammonites. The point is, the origination of new species increases after mass extinctions. And with a mass extinction like the Permian-Triassic, the largest the planet has ever seen, origination rates afterwards were off the charts. Let's review. Considered the worst mass extinction ever, the Permian-Triassic extinction occurred 252 million years ago. Over the course of 60,000 years, 96% of marine life and 75% of land life died, clearing the way for reptiles to take over in the Mesozoic era. Since the Cambrian explosion, there have been 5 mass extinctions in Earth's history. After each one, Earth saw major increases in biodiversity. Obviously, because once you wipe out most of the life on the planet, life can only increase from there. So without the Great Dying, many of the species we know and love today, and the dinosaurs, which we know and love 66 million years ago, wouldn't have had the chance to evolve. Thanks for watching.